So this is a quick video to go over optimization problem. And so this the problem that I'm reading from is on web work. So it's homework 12, question number 6. And it says this. It says a fence is to be built to enclose a rectangular area of 270 square feet. So I'm going to go ahead and sort of draw a picture as I read this. So here's my fence. And the fence along 3 sides is to be made of a material that costs $3 per square foot. So some of my material costs $3 per foot. And on the 4th side, the material costs $12 per square foot. And what I'm trying to do is I'm trying to find the dimensions of the rectangle that are the most economical. And so to that means it costs the least amount of money. Okay, so 3 sides of this thing are going to be $3 a square foot, and one side is going to be $12 per square foot. So if something like this in blue, right, that's going to be one amount of my fencing, and then in green we're going to have the more expensive fencing, which is going to be $12 a square foot. Okay, so if I put some dimensions on this, it has to be x by y, right? So this rectangle has width x and length y, and I want to find the values of x and y so that I do get an area of 270 square feet, but I have the least cost. Okay, so I need two equations here. One is going to be my constraint. So the constraint tells me that I need to have a big enough area. So x times y has to give me 270. And then I have to set up my cost function. All right, so the cost of this fencing, I know that there's x's and y's on both sides here. So the total perimeter is going to be x, y, x, y. So 2 x's and 2 y's. But this x costs me $3 per square foot. So that's going to be a $3 times this length, and a $3 times this length, and $3 times our third length. So if I think about the blue length, what I get there is I get $3 times however long that is, and so the length there is going to be 2x plus y. And then for my green, there's only one y there, so that's going to be $12 times my y. Okay, so looking at this, my cost function in 2 variables is c of xy is 6x, and this is going to be plus 3y plus 12y is plus 15y. Okay, so what I'm going to do is, in order to use calculus on this thing, we want to go back, and I'm going to look at my constraint that I'm going to highlight here in red. And what I want to do is I want to use that to get rid of one of my variables now. It doesn't matter if I get rid of x or y. So we can just say, here, this is x. So x is going to be equal to 270 divided by y. And so then I can go ahead and replace this x now. And what I'll be left with is a cost function based on y, which is 6 times 270 over y plus 15y. Okay, so with this equation now, what you can do is use calculus, right? So you're going to take the derivative, you're going to find an interval which you want to optimize over, look for the critical points, and that should give you the value for y that you're looking for. And then you can go ahead and use your constraint equation over here to determine what the value for x is. Okay, so this is a good start on homework 12 number 6, and then from here I'll leave it up to you to finish it.